Okay, so this was the next thing that Alan did. He talked about the fundamental theorem of algebra. I think he called it that. And basically it says if P of x is degree n, then P of x has n solutions or n roots. So for something like this, nice simple polynomial, it has degree 2, so it should have 2 roots. And we can factorise that. It's a difference of 2 squares, so it becomes x plus 3, x minus 3 equals 0. Therefore, x equals minus 3 or x equals 3. And it's degree 2 and it has 2 solutions. It has 2 factors. Something like this, it's degree 3 because the highest power is 3. And we can factorise this. We can take a common factor out, x outside of x minus 4. X outside of x squared minus 4 equals 0. And when we write this out, it becomes x minus 2, x plus 2 equals 0. So what you have is it's degree 3 and it has 3 roots. This is degree 2 and has 2 roots. What we also should notice is if we wanted to graph the polynomial y equals p of x, this cuts at minus 3 and 3. So it would look like this. It's a nice simple polynomial or parabola. This one cuts at 3 spots. So it cuts at 0, 2, and minus 2. 0, 2, and minus 2. And it's a cubic, so it would look like this. Okay, where this is minus 2, this is 0, and this is 2. So that's the fundamental theorem of algebra. Polynomial of degree n has n solutions or n roots. So how does that look for something like this? X to the power of 4 minus x squared, we're saying it should have 4 roots. So let's solve this. We can take a common factor out, x squared equals x squared minus 1 equals 0. Therefore what we get is x squared, x plus 1, x minus 1 equals 0. And straight away the fundamental theorem of algebra has fallen down because this only has three zeros. X equals 0, x equals minus 1, and x equals 1. But what we are saying is that this is a double root, or it has a multiplicity of 2. 2 roots are happening at x equals 0. So if we were to graph it, y equals, we know it crosses at 1, we know it crosses at minus 1, and it has a double root here. So really what it's going to do, it crosses once here, and it crosses once here, and here there's a double root. Now a double root is like an x squared, so it's going to look like that, and that's going to be our function, or our graph of our function, y equals x to the power of 4 minus x squared. Here there's a double root, so it's like a y equals x squared, just comes up and touches. And that's how we get around, so the fundamental theorem of algebra, a degree 4 polynomial has 4 roots. It has 1, 2, 3, 4, because this has a multiplicity of 2. So that's how they get around the first problem. And this is how they get around the second problem. Something like this. It's a polynomial, degree 2, so it should have 2 roots. How are we going to solve this? Because I can't think of 2 numbers that times together give 5 and add together to give minus 4. It just doesn't work. So I'm going to use the formula. Minus b plus or minus the square root of b squared minus 4ac all over 2a. Now remember, we're saying this should have 2 roots. So we're going to get 4 plus or minus b squared is 4 squared minus 4 times 1 times 5 all over 2 times a, which is just 2. And what we get there is 4 plus or minus negative 4 all over 2. So here's an issue, because we're saying the fundamental theorem of algebra says that it should have 2 roots. It's degree 2, so it should have 2 roots. And normally we might say that there's no solutions. And you may have heard some people, Alan, say there's no real solutions. And that's the key word, because we're going to make up something, as mathematicians do, so the theorem always works. And we're going to say that the square root of -1 equals I, this imaginary number I. And so what we get is this becomes 4 plus or minus the square root of 4 times the square root of -1 all over 2. And suddenly we can do it. This is 4 plus or minus the square root of 4 is 2, and the square root of -1 is I. All over 2, which when we factorise is 2 plus I, or 2 minus I. And so suddenly we're back to degree 2 polynomial, and it has 2 solutions. These are complex solutions. This is the real part. This is the imaginary part. The real part and the imaginary part. Now, the next thing that Alan will start talking about is that if the polynomial starts off in the real sector like this, all these numbers are real numbers, then the answer will always be 2 plus I, 2 minus I. These are called conjugate pairs. Okay, so if one was 3 plus I, the other one would be 3 minus I. If one was 6 plus 2I, the other one would be 6 minus 2I. So they always come in pairs, and these are conjugates. The real part's the same. The imaginary part is just plus or minus. So that's where we're going to go to next with imaginary numbers, which is really just so the fundamental theorem of algebra, that the x squared, degree 2, has 2 roots. Thanks. I'm just trying to find the stop button.